Okay, welcome back, Algebra 2 students. In this lesson today, we're going to go over section 2.2, which is solving linear systems using elimination. So this is pretty similar to what we were doing last time, where we have x, y, and z, and we're trying to figure out what variable or what values for those variables are going to make each of these equations true. But this time, we're going to use elimination the whole way through because none of these are going to necessarily have easy to isolate variables like we were with substitution. If we try to get any of these by themselves, we're going to introduce unnecessary fractions, and it's just going to make it harder on ourselves. So in this case, we're just going to use elimination all the way through. And in this first problem, notice that in the top equation, you have variables of just x and y, but in the other two, you have variables of x, y, and z. So just like our strategy last time of trying to get from three equations with three variables, and I'm going to write that down somewhere. So our strategy here is to go from three equations with three variables to two equations with two variables because we know how to solve those pretty easily now. And so going back to what this first equation is saying, it already has just x and y. So we already have one equation with one variable. We just need another equation that is, in this case, missing z because this top equation doesn't have a z. And if you notice, we can add equations 2 and 3 together, and that will get rid of z. So let's go ahead and do that. If we add those two equations together, we're going to get 5x plus 6y. The z's will cancel, and we have negative 19 plus 6, which is going to be negative 13. And now notice, we have the equations negative 5x plus 2y is equal to negative 11 from the first equation, and we have the second equation that we just created by eliminating z, 5x plus 6y is equal to negative 13. And the same strategy here is that we want to get rid of one of our variables, and coincidentally, we can actually add equation or these two new equations together to get rid of x. If we do that, the x's go away, and we're left with 8y is equal to negative 24. And since we know that 8y is equal to negative 24, we can divide by 8 on both sides, and that gives us y is equal to negative 3. So we've already isolated a variable, and now that we know what one of our variables is equal to, we can actually solve it. We can solve for another one of our variables, in this case x, since we had two equations with just x and y. We can now take this value and we can plug it back into one of the other two equations. It doesn't really matter which one we pick. I'll go with, say, the bottom one. If we do the bottom one, that means we have 5x plus 6 times y, but we now know that y is negative 3, and that's equal to negative 13. If we multiply out 6 times negative 3, that's going to be negative 18 is equal to negative 13. And if we add 18 to both sides, the 18s will cancel and we're left with 5x is equal to 5. Lastly, if we divide by 5, and that gives us x is equal to 1. And now that we know that x is equal to 1 and y is equal to negative 3, we can plug into one of these two equations up there to find z. And again, it doesn't matter which equation we plug into. I'll choose the bottom one, and that means that we have 2 times x, which is 1, plus 4 times negative 3, plus 4z is equal to 6. 2 times 1 is just 2. 4 times negative 3 is negative 12. We have plus 4z, and that's equal to 6. 2 minus 12 is negative 10. Plus 4z is 6. Adding the 10 to both sides, we're going to get 4z is equal to 16. And now dividing by 4 on both sides, that means that z is going to be equal to 4. So now that we know that z is equal to 4, we have that x and y are equal to 1 and negative 3. We can write our solution as x comma y comma z is equal to 1, comma, -3, comma, 4. And so this is how we write our answer as a coordinate. And these are the values of x, y, and z that will make every single one of these equations true. And so that's our first example. Let's see what we have for example number 3. So let's see. Well, we have variables x, y, and z in all three of these equations. Okay, that's not too bad of a problem. And notice that if we try to add some things together, like for example, what we're going to try to do is basically hunt for any variables that we could add together from these equations that will make things cancel. And if you notice, equations 1 and equations 2, this one has a negative y and this one has a positive y. That means that if we add these two equations together, the y's will cancel. So that means we have 2x minus y minus z is equal to -10 for the first equation, and the second one, 2x plus y minus 3z is equal to -6. So this is just equations 1 and 2. I just rewrote them because I didn't really have room under, between that one and the third equation. But if I add these two together, I get 4x, the y's cancel, and then minus 4z is equal to -16. Notice that we could also use the first equation and the third equation as well. If we do that, we have 2x minus y minus z is equal to -10, so the first equation again. But then let's add it with the second equation. The second equation is -3x plus y plus 2z is equal to 14. And if we add these two together, we're going to get -x, the y's will cancel, and we have -z is equal to +4. So we have these two equations now in just x and z. I'm going to rewrite them so that they're a little bit nicer. So we have the first equation that we obtained, and the second one I'm going to stack it on top of it. Well, below it, rather. But these are our two new equations. And the goal here is that we want to, again, eliminate either one of the variables here. And what we can do, like say if we wanted to eliminate x, and this will actually work for z, so we're actually going to get an interesting solution here. But the only way that we're going to get x to eliminate, or z, is if we multiply the bottom equation by 4. If we do that, and we keep the top one the same, so I'm going to say that I'm multiplying it by 1, the top equation stays the same. We have 4x minus 4z is equal to -16. But if I multiply the bottom equation by 4, I'm going to get -4x, -4z, and that's equal to +16. And now look at that. When we add these two equations together, we're going to get 4x and, oh, sorry, I made a mistake here. This minus z and this plus 2z, that's going to be a plus z. Sorry about that. So we have -x plus z is equal to +4. That actually changes our answer a little bit right here. Okay, and that works out, because now if I multiply this by +4, this is going to be a plus 4z. And now we get a cancellation here. We have -4z plus 4, -4z plus 4z. We get 0 over here is equal to -16 plus 16, which is also going to be 0. And since we have 0 is equal to 0, we can say that this is infinitely many solutions. And that's our final answer. Moving on to our next problem here. Same thing. So we have a lot of different choices of things that could eliminate here. Let's roll with, sure, let's do x. Notice if I add equations 1 and 2 together, the x's will cancel. And it looks like y will cancel as well. So let's see what happens. We have 3x minus 2y plus z is equal to negative 6. And we have negative 3x plus 2y plus z is equal to 4. If we add these together, x's will cancel, y will cancel, and we just have z plus z, which is 2z, and that's equal to negative 6 plus 2. Sorry, negative 6 plus 4, which is going to be negative 2, which tells us that z, if we divide by 2 on both sides, z is equal to negative 1. Now that we know that z is equal to negative 1, okay, that's cool. Let's also see what happens if we, say, add equations 1 and 3 together. Because notice that the x's will cancel, but this time the z's will cancel too. We'll get an equation in, just with y. So if we have that the first equation, 3x minus 2y plus z is equal to negative 6, and we add it with the third equation, negative 3x minus 2y minus z is equal to 14. As mentioned, the x's will cancel and the z's will cancel. This gives us negative 4y is equal to positive 8, because negative 6 plus 14. If I divide by negative 4 on both sides, and I do want to circle that because that is pretty important, but if I divide by negative 4 on both sides, that's going to give us y is equal to negative 2. And now that we know that y is equal to negative 2, we can actually substitute both of these values back into any one of the equations to find x. I think I'll roll with the first one since we already have a positive x here. It'll mean a little bit less work we have to do to isolate it. So we have 3x minus 2 times y, which we know y is equal to negative 2, and then plus z, which we know is negative 1, and that's equal to negative 6. So just multiplying some stuff out, we still have our 3x. We have negative 2 times negative 2, which is going to be positive 4. And when we add a negative number, it's really just subtracting that number. So it's going to be minus 1 is equal to negative 6. And now if I combine 4 minus 1, 4 minus 1 is just going to be 3. So I have 3x plus 3 is equal to negative 6. If I subtract the 3 from both sides, I get 3x is equal to negative 9. And if I divide by 3 on both sides, I get x is equal to negative 3. So we know what x, y, and z are. Now we just want to write our answer as a coordinate. So we have x, comma y, comma z is equal to negative 3, negative 2, and then negative 1. And so this is our final answer. Okay, so moving on to number 7, let's see what happens. First, let's see if there's any variables that we want to eliminate. Let's see, so we have 4x, and hey, look, 4x and negative 4x. Let's add equations 1 and 2. Also notice that equation 2, sorry, not equations 1 and 2, 1 and 3, but notice that equation 2 also doesn't have an x term at all. So this is kind of nice because we have 4x and minus 4x. We'll get an equation without x if we combine equations 1 and 3. And then we already have another equation without an x, and that means that we'll already have two equations with two variables. So if we take equations 1 and 3, and we add those together, the x's will cancel. We have negative 4y plus y, which is going to be negative 3y. And then we have 2z minus z, which is just c. And now we have negative 4 plus 15, which is just going to be positive 11. So we're going to take this equation, and we're going to take this middle equation here, and let's see what happens. We have 3y minus c is equal to 13. And notice that if I add these two equations together, the y's will cancel, and so will the z's. So we know that we're going to get a special solution here. So y's and z's cancel. We get 0 out of this. But we also have 11 plus 13, which is going to be 24. And anytime we arrive at this, a false statement like this, what we call a contradiction, this is going to tell us that we have no solution. So anytime we arrive at a contradiction, we have no solution and we're done with our problem. That means that there's no possible values for x, y, and z that would make all of these equations true. You might be able to find two, at most like two variables that will make these equations true, but it won't make all three of them true simultaneously. So, all right, and let's look at number 9. So, with number 9, we have a similar situation where if I add equations 1 and 2 together, the x's will cancel, and then we can move on to equations 2 and 3, and the x's will cancel again. So if we do that, we have negative 2x plus 4y minus 2z is equal to negative 20. And then we have 2x minus y minus 4z is equal to negative 7. If I add these two together, x's cancel. We have 4y minus y. That's going to be 3y. We have negative 2z minus 4z, which is minus 6z. And then we have negative 20 minus 7. It's going to be negative 27. Okay, and so that was using equations 1 and 2. Now let's use equations 2 and 3 to also eliminate x. If we do that, we have 2x minus y minus 4z is equal to negative 7. And then the third equation, negative 2x plus y minus z, is equal to negative 13. This is going to work out nicely, because not only are the x's going to eliminate, the y's will eliminate as well. That will just leave us an equation with just z. So when we do negative 4z minus z, we get negative 5z, and we have negative 7 minus 13, which is going to be negative 20. If we divide by negative 5 on both sides, z will be equal to negative 20 divided by negative 5, which is going to be a positive 4. Now that we know that z is equal to positive 4, we already have an equation with just y and z. We can actually swap out this z in this equation to find y. So if we do that, we now have 3y minus 6 times z, which we're going to replace with a positive 4, and that's equal to negative 27. If we if we do negative 6 times 4, that's going to be negative 24, so we have 3y minus 24 is equal to negative 27. And if we add 24 to both sides, because we're still trying to get y by itself, we're going to get 3y is equal to negative 3. And sure enough, if we divide by 3 on both sides, we'll get y is equal to negative 1. Now that we know that y is equal to negative 1, we can plug both y and z back into any of these three equations, and we'll find x. I'm going to personally choose the second equation because we already have a positive x term there. So let's see what happens. We have 2x minus y, and I recommend putting that in parentheses. So minus y, and we know that y is negative 1. It's going to be minus negative 1. We don't want to mess up the sign here because it's really going to be a plus 1. But then we have minus 4 times z, and z is 4, and then that's equal to negative 7. So, as mentioned, we have 2x minus negative 1 is really going to be a plus 1, and then minus 4 times 4, which is really just going to be minus 16, and that's equal to negative 7. If we combine 1 minus 16, that's going to be 15, or negative 15, so we have 2x minus 15 is equal to negative 7. Still want to get x by itself, so we're going to add 15 to both sides. We have 2x is equal to negative 7 plus 15, which is going to be a positive 8. And now if we divide by 2 on both sides, we get x is equal to 4. Now that we have all three of our variables, we can state our answer as a coordinate, and that's going to be x comma y comma z is equal to 4 comma negative 1 comma 4. And there we go. All right, let's look at number 11. Number 11, let's see what we have here. All right, well first let's notice that this middle equation does not have an x term. And because it doesn't have an x term, hopefully we can eliminate x using the other two equations. And it looks like, yeah, we have negative 2x and we have positive 2x. If we just add equations 1 and 3 together, we'll get rid of x, and that means we'll have two equations without x, meaning that it's just two equations with x, or sorry, with y and z. So if I take equations 1 and 3, we have negative 2x plus y plus z is equal to 11. If I then add that with equation 3, we have 2x minus 3y plus 2z is equal to 8. Let's add these two equations together. The x's will cancel. We have y minus 3y. That's going to give us negative 2y. Then we have z plus 2z, which is going to give us 3z. Lastly, we have 11 plus 8, and that's going to give us 19. Now that we have two equations with two variables, we have the other equation from the middle. I'm just going to write underneath this one that we just got. We have from the middle 2y minus 3z is equal to negative 6. And if I add these two equations together, the y's cancel, but so do the z's. So we get 0 over here. But notice that we have 19 minus 6. 19 minus 6 is not 0, it's equal to 13. And because 0 is not equal to 13, because this is false, we actually get no solution out of this one as well. So we have no solution. All right. We have two more examples to go. Let's see what we have here. For number 13, let's see, variables that will eliminate. If we look at the x's, nothing's going to eliminate easily here. Not as easy as the y's, at least. Because notice, if we add equations 1 and 2 together, the y's will cancel. And then we could also add equations 1 and 3 together, and the y's will cancel as well. So let's use those, equations 1 and 2. We have negative 2x plus y minus 2z is equal to 8. The second equation, negative x minus y minus 3z is equal to 1. If we add these two equations together, we're going to get negative 3x, the y's cancel, minus 5z is equal to 9. Okay, and now let's try to eliminate y again. We already used equations 1 and 2. Let's use equations 1 and 3 this time. That means we have negative 2x plus y minus 2z is equal to 8. And so that's our first equation. The third one in this case is negative 4x minus y minus z is equal to 10. Adding these two equations together, we're going to have negative 2x minus 4x is going to be negative 6x. The y's cancel, and we have negative 2z minus z is going to be negative 3z. And then we have 8 plus 10 is going to be 18. So we have two equations with just x and z. I'm going to rewrite them on top of one another. Okay. And so notice that, well, nothing's going to eliminate quite yet, not as is. What we can do is we can multiply either one or both of these equations by some number that will make the variables cancel. And so notice that if I do 3 times 2, that's going to be the same thing as 6. So then if I multiply this top equation by 2, this will get us to cancel. But notice that in order for the variables to cancel, they need to also have opposite signs. So like up here we had plus y and negative y. Plus y and negative y. Up here, if I do negative 3 times 2, that's going to give us negative 6. But we don't need negative 6 because we have negative 6 here. We need positive 6. So instead, we're actually going to multiply this by negative 2. That way, when we do negative 3 times negative 2, we get a positive 6x, which when we combine with this bottom equation, the x's will cancel. So we'll do negative 5 times negative 2 It's going to be 10y, and then we have 9 times negative 2, and that's going to be negative 18. Now, if we keep the bottom equation the same, I just denote that using a little arrow with the 1, because anything times 1 is going to be itself, right? So, multiplying everything by 1, in other words, just keeping everything the same. And let's see what we get here. We have 6x minus 6x, that's 0. Then we have that 10y minus 3y, sorry, ooh, why did I write a y there? Sorry about that. That is a z. We have 10z minus 3z. That's going to be 7z. And then negative 18 plus 18, that's going to be 0. And 7z is equal to 0. If we divide by 7 on both sides, z is going to be equal to 0. And now that we know that z is equal to 0, we can take this and we can find x. So if I plug into, say, this first equation here, we have negative 3x minus 5 times 0 is equal to 9. Negative 3x, and then minus 5 times 0, that's really just going to go away. And then that's equal to 9. Negative 3x is equal to 9. We can just divide by negative 3 to get x by itself. Dividing by negative 3 on both sides, that's going to be negative 3. Circled that kind of poorly. There we go. So x is equal to negative 3. Now that we know that x is equal to negative 3, we can find y. So we're going to go up to any one of these equations, and I like to always choose the equation with a positive variable of whatever we're trying to find. So I'm going to use the top one. So we have negative 2x, but x is negative 3, plus y minus 2 times z, but z is 0, and that's equal to 8. Well, negative 2 times negative 3 is really just 6. And we have y, and negative 2 times 0 goes away, so it's really just equal to 8. Now if we subtract 6 from both sides, we have y is equal to 8 minus 6, which is 2. So now we know y is equal to 2. And since we know what all three of our variables are, let's write these as a coordinate. We have x, comma y, comma z is equal to x, which is negative 3, y, which is 2, and z, which is 0. And so that is our final answer. All right, last one. So let's see. Okay, well, notice that in the top equation, we're already missing a y. That's good. And if we use equations 2 and 3 together, we're also missing y. Or we can add those two equations together to make y go away. So if we just add those two together, I'm not going to rewrite them just because I already have space below them. But if I have 4x plus x, that's going to be 5x. Negative 2y plus 2y is going to go away. And then negative 3z minus z is going to be minus 4z. And then we have 19 minus 3, which is going to be 16. Okay. And we already have this top equation here. I'm going to write it right below what we just had. Negative 5x plus 4z is equal to negative 16. And hey, would you look at that? If I add these two equations together, the x's cancel, the z's cancel, we get 0. But then we have 16 minus 16, and we also have 0. So anytime we arrive at this 0 is equal 0 statement, because this is true, we're going to say that we have infinitely many solutions. And so it's beyond the scope of this class to figure out what those solutions are. So we'll just arrive at this solution if we have infinitely many of them, and we're going to stop right there. So that's it for example 15. So hope that you found this video helpful. Of course, your homework is the evens, so go ahead and do that and then submit them when you're done. All right, hope you have a good day. Thank you.